Hello, everyone, and welcome to our webinar today. I'm John Ricco. I'm the Executive Director here at the Architectural Precast Association, and I'd like to thank you for attending today and thank our presenter today for being here and all of you for taking the time to participate. Before we go ahead and get this session started, I just want to do a few housekeeping things and talk a little bit about some upcoming events and information that we've got coming up. So as you are probably aware, the upcoming annual convention is October 6th through 9th in Delray Beach, Florida. We have some great educational sessions lined up for you, some of which are highlighted here. We know it's going to be a great event, so I encourage you to check it out and potentially join us down in Palm Beach County in October. So looking forward to that event. In addition, we've got our 2024 spring workshop that we're mapping out, and that will be in Tacoma, Washington, just south of Seattle. It will be on ultra high performance concrete. We know that's going to be a great educational opportunity. You can see pictures there. Half of the sessions will be hands-on, actually in the plant. And this is Tim McGordy's brand new facility that he's got out there just outside of Seattle. So we encourage you to check out our website for information as it becomes available. We do have the dates. It's going to be April 3 through 6 in Tacoma. And we're working on finalizing all the educational content right now. So that should be a great event. We do have a couple more upcoming webinars throughout the rest of the year. The next one being in October, Managing Air and Concrete with Terry Harris. So mark that one on your calendar, as well as in mid-November on the 15th, we've got one on the transformational power of concrete stain. So that's just a few of the upcoming educational opportunities. And we also like to remind everybody that we've got some great member saving programs for office supplies through ODP, which is Office Depot's online business to business spinoff. So check out our website for information on how you can save a lot of money on office supplies if you are an APA member. And then finally, this is just one of the many ways that you can earn continuing education. So we have this chart up on the website to help it make easy for those of you who's APA certified personnel and need those CE credits. So check that out as to the many ways that you can learn about what you need to in order to continue get your CE credits. So with that, we're going to move right into our webinar here. And I will take a moment to introduce our presenter today, Jim Renda. Jim has a vast amount of experience. Jim, right as we went as we went live here, my Word document crashed with your bio, but I'll give you an opportunity to talk a little bit about yourself. I know you have some significant sales experience and sales and marketing experience, generally working for companies like Arby's and Nike, and you've been involved in precast and the concrete world for a little while too. So with that, I'll give you a moment to expand upon your bio that just conveniently crashed on me as I was loading this up, and then we'll get on with your presentation.
All right, thanks, John. I'd like to thank the APA for the opportunity to present this webinar and clear up a lot of the misunderstandings and confusion about what release agents are, how they work, and how you're supposed to apply them. About my background, I've been with Crescent as head of sales and marketing for the last 9 years, but I've been associated with the company for the last almost 30 years. I started out as a consultant to them on sales and marketing issues. So my previous background includes positions at, as John said, Nike and Champion Spark Plug and Arby's. Quite a diverse background, but all sales and marketing related. About Crescent, a little bit about the company. We just celebrated our 77th anniversary in business. We're a small family owned and operated company, third generation. The founder is the grandfather of Mike Beatty, who is the current president of the company. And he was a chemist who developed quite a number of amazing formulas. And we followed that tradition throughout those years. So we operate out of Northwest Ohio, and we distribute around the world. We sell a lot of product throughout the Americas and beyond. So that's just a little bit about the company. Now, the presentation. Because as I go around to meetings and to plants, I see a lot of practices that are being followed in the plants that are not to specifications. So in order to address that, we worked with Hanley Wood University about 3 years ago to develop this presentation about release agents in general. This is a industry focused presentation and not specific to our individual company or any one individual company. So I don't expect you all to become experts on release agents by the end of the presentation, but if you can pick up a tidbit or two that you can take back to your production folks in the plant, or can save you some money on the use of the product, then this hour will be definitely worth it. So first of all, release agents are, there's all different types of names for them, and they're for every release agent that's out there. There are thousands and thousands of different formulations and the composition of the products, and their specific purpose release agents. So a lot of people think that release agents are interchangeable, and that is not true. Today, with the high demands of architectural concrete in particular, there are all kinds of different formulations that will get you the best results. So it's good to work with the manufacturer of that whatever brand you're using, and to look at the literature that they have available before you start a project. So one release agent might be good for one particular project you're working on, but it might not be the best for a special task project. All of architectural concrete should look like this piece that you see on the screen. This is a little sample piece that we made up for the 75th anniversary of our company. We worked with US Formliner on this. They created the Formliner, and it's particularly difficult with all kinds of different elevations and elements in there to highlight the power that release agents can do. So you see no bug holes, you see no staining or discoloration, and all of the features of that Formliner pop out at you as you look at it. So hopefully with some of the tips today, you'll be able to achieve that in all of your architectural concrete. So the course description is to get a better understanding of the wide variety of release agents that are out there, the different performance characteristics. There have been a lot of recent innovations in our segment of the industry that can make a big difference. But they are very application specific. So please keep that in mind as you're looking at options. So some of the things we want to cover are to understand the importance of form release agents in solving concrete challenges. And we all know we all have concrete challenges. You examine the two different types of release agents and how they work and what they're used for, and explore the appropriate applications for different release agent formulations, and to review the important considerations and steps for applying release agents. As I go around, I see all kinds of different devices being used to apply the release agents, and 95% of the time, you could use a better device, a better type of sprayer. So we'll get into that a little later in the presentation. So we want to understand the importance of form release agents in solving concrete challenges. As the industry has evolved over the last 70 or 80 years, architectural has become more important of an element. And so the surface appearance of the concrete is an extremely important consideration. And so how you achieve that is very important. And it's good to understand how release agents can help in order to get you that architectural finish. Architectural versus structural. Architectural concrete is essentially exposed. So after completion of the concrete, it's exposed to the viewer. So you see it after the structure is completed. Structural is more of a functional element, such as bridges. So there's different considerations in each of those. So how do you improve the aesthetics of the concrete? Some of the very basic things are you want to minimize the potential for bug holes. You want to use good, clean formwork. Keep in mind that what the concrete that you strip from the form is going to be a true reflection of that form. So you don't want any imperfections on that form surface. And don't overlook form release agents when designing and specifying concrete. Release agents are specified in some architectural projects, but not enough, and they should be. So that's something to consider. A lot of times that decision as to which release agent a plant is using is made by a purchasing manager who's just looking at price, or looking at or decided by somebody in production. And that's not necessarily the best release agent for the project. So it's good to consult with whoever your provider of release agent is. Talk to their technical people and make sure that the release agent you're using for a project is the right one. So what are release agents? They are essentially materials that let you easily separate the form from the hardened concrete. A lot of names for it as I go around the world. They're called demolding fluids, debonding agents, demounting agents. There are all kinds of descriptions. Also, I mean, everybody knows that form oil, that term, is interchangeable with release agents. But there really is a big difference between a form oil and today's reactive release agents. And we'll get into that. Release agents, at the very basic, they ease the form work removal. They should also extend the life of the form that you're using to protect that form surface, so you can use it again and use it multiple times and get a good life out of it. Improve the smoothness and texture of the concrete, and your release agent manufacturer will help determine the ideal release agent for consideration. These are some of the types of form liner materials that are used, form and form liner materials that are used. And all of those, except for the bottom three, most of today's typical chemically reactive release agents will work fine with all of those materials. If you're doing anything with natural rubber, latex, or SBR, which is a synthetic rubber, which is even softer than natural rubber, you don't want to use a petroleum-based release agent on those. That will damage those softer materials. Most of those different materials, they require a castor oil and rubbing alcohol combination, which are available from some manufacturers. A lot of producers who are using those, they actually mix that themselves. But you never want to use a petroleum-based release agent with those softer materials. ACI 347, section 6.4 has a good definition of what release agents are and how they should be used. And I would call your attention to 2 points in this description. Right there in the middle where it says, where concrete surface color is critical, effects of the coating, sealing, and release agents should be evaluated. A lot of form oils, most form oils, and some varieties of chemically reactive release agents, they use as a base a recycled oil, sometimes called reformulated. It's a waste oil. And that can cause staining and discoloration. And particularly if you're doing something like a sound wall project, it'll get you color variations from panel to panel or from batch to batch, depending on what you're using. So be sure that you use a 100% virgin ingredient release agent to avoid those types of color issues. It also says you should be applied to the form surface. Be sure that the adhesion of such treatments will not be impaired or prevented by the use of coating, sealers, or a release agent. As far as release agents are concerned, you don't want to use, if you're going to be doing a treatment after stripping, you don't want to use a release agent that has waxes or silicones in it, because those can interfere with that stripped concrete. You'll get blotchy if you're painting it or staining it. You could get blotchy surface quality. So please keep that in mind. So our job as release agent producers is to reduce bug holes as much as possible. That's always a challenge for every concrete producer. And our job is to help you reduce that. And you also want to protect formwork. That forms are very expensive these days, particularly steel forms. Steel has gone up 2 and 3 times in price over the last few years. So you want to treat those very carefully and be very careful in how you clean those. Bug holes. We got a lot of different names in our industry for different things. Bug holes are also called pinholes, blowholes, surface voids. They're typically small, regular or irregular cavities that result from the entrapment of air bubbles on the surface of vertically formed concrete during the placement and consolidation of the concrete. Release agents can eliminate that picture of that concrete. I'm sure a lot of you have seen concrete that looks like that. With the right release agent, with a chemically reactive release agent, all but 2 of those holes that you see in that piece, those bug holes, could be eliminated by use of the right release agent. So it's an aesthetic concern, but it can cause problems when painting or when those voids are larger than 1 inch. Release agents can't solve those big bug holes. That is typically a problem that's created by the concrete mix or an inferior type of aggregate that's being used in the mix. So, what causes bug holes? It can be a dent or some other malformation of the form material. If you have a ding in the form, that's going to show up on the concrete. It could be that form material itself. Some plywood with that's not coated will leave those impressions. A lot of times, what we see, it's excess release agent. A lot of people that can't believe that, but if you put too much release agent onto the form, that release agent has to go somewhere after that pour. So if you have any standing or pulling of release on that form material, especially in highly detailed forms or form liners, you're going to get bug holes because that's got to go somewhere. And it also could be caused by improper vibration and the placement of the concrete. It's always important to pour the concrete slowly enough so that you reduce the air entrapment as much as possible. And as I said before, it can be an irregular size aggregate that causes the bug holes. When you're using self-consolidating concrete, you can get problems with the mix design. If it's too dry, not wet enough, or not enough viscosity, or has the wrong admixtures, you could get bug holes. And the placement of the concrete into that form is critically important with SCC. And of course, the using the wrong release agent can be a problem also. So you use SCC or a highly fluid concrete to minimize bug holes. You use a vibrator with the proper frequency and amplitude. You use well-graded, clean aggregate. You don't want it wet or excessively dirty. That can cause problems. You use the concrete with sufficient paste and volume and viscosity, and you minimize the drop height of the concrete in order to avoid trapping air. And you place your concrete slowly. That will all minimize bug holes. So everybody knows how expensive forms are, and every production crew wants to get the maximum life out of those forms that you're using. So ACI's Guide to Formwork for Concrete says that the cost of formwork can be greater than half the total cost of the concrete structure. So you want to take precious care of those when using them, cleaning them, and storing them. Release agents cost 80% less than the labor for cleaning formwork. If you're getting a lot of concrete sticking to the form surface, or you're getting a lot of oil that's left on that form surface, that takes time to clean. And it also takes time to repair the concrete. So you can see that you can save a lot of money just by doing the job right the first time. Our second objective is to examine the two different types of release agents and how they work. Those two types are barrier types and reactive types. There's a different chemistry with each of those. And I'll go over just what that difference is here in just a second. Barrier types are the first release agents that were used when precast was starting out. Those are typically a type of petroleum oil. The first release agent that was used, first form oil that was used, was diesel fuel. Can't do that these days. There are a lot of considerations as to why not, but also barrier types include home heating oils, paraffin wax, new motor oil, and that waste oil that I mentioned earlier, which is typically a crankcase oil. So those can, you apply a lot more of that. You have to apply a lot more of that in order to create that slippery surface. And that's what you're going to achieve with a barrier release. You're going to get a slippery surface. It's going to separate, but you're not going to get that high definition that everybody wants for architectural concrete. So they cost more per square foot. They may cost less per gallon, but you're using a lot more of a barrier type than you are of a reactive release agent. They can cause environmental issues. The VOCs in all of those materials is higher than recommended by state and federal EPAs. So you got to be careful of that. Most of those are not EPA approved, and they can cause staining and inconsistent quality. And the volatile oils, they evaporate quickly, so they have to be reapplied because you have no chemicals that are in that barrier release in order to create that separation. You have to rely on the slippery surface. So, and a lot of VOCs are released into the atmosphere. So for architectural, please don't consider barrier type release agents. Always use chemically active release agents. And a chemically active release agent is it's one that reacts with the calcium, the lime in the fresh cement paste to create separation at the molecular level. So it's on a very, very, very fine surface that creates that separation. And that's all you need. That's why you need so much less of a reactive release agent than you do of a barrier release. Typically what that active ingredient is, a lot of people ask what that is. It's mostly a fatty acid or modified fatty acid dissolved in a carrier such as petroleum oil, vegetable oil, water. We have a synthetic release agent now, but it's a fatty acid, and there are different types of fatty acids. There are produced by humans, animals, and plants. And so how much of that fatty acid is in that release agent and the quality of that fatty acid, that will make a difference in how that concrete strips and how it appears. The goal of all chemically active release agents is to produce fewer bug holes, stains, and surface irregularities than barrier types. Commonly used for architectural concrete. And a lot of people don't know but that reaction, that will stay on the formed surface for up to 2 weeks, as long as it's not exposed to like a heavy rain. So ideally you want to be doing that in the plant, but you don't have to pour immediately. Ideally, you want the carrying agent to evaporate and just have those active molecules on the formed surface to create that separation. That will get you the best formed surface. And it only requires ultra thin. It's 7 times less than those barrier release agents that I listed just a bit ago. So as your cost per square foot is significantly less than a barrier release, and it's much more environmentally friendly. Everybody is concerned about the environment these days. And so the best release agent for the environment is going to be a reactive release. So those fatty acids, they create a slippery, non-water soluble soap that allows the form to easily release from the hardened concrete. It works in over a variety of temperatures. Some of the factors that determine the final appearance of the concrete are the ambient temperature, the chemical nature of the attached group, the wetting properties of the release agent, and the speed of that calcium fatty acid reaction. Release agents, our job is to balance what we're trying to achieve here with the concrete surface, with the appearance of the finished concrete, clean forms to reduce cleanup time as much as possible. And we've got to weigh environmental and OSHA considerations. There are regulations that are in place in every state and country, and it's important that producers comply with those. Non-compliance can get you fines and penalties, and you won't want to avoid that. No two proprietary release agents produce the exact same concrete surface, color, and texture. So it's good to find the one that you like, the kind of surface that you're going for, and stick with that. So you always consult with the manufacturer to specify the proper formulation. Now, every release agent out there, and there are thousands of them, everyone has two documents that you should have when you're working with that release agent. It's the one is the safety data sheet, which gives you critical information about how to use that release agent and some of the ingredients in it and how the reaction that you can get if you get it on in your eyes or on your face, and also the specification sheet, and that tells you the recommended way to apply that particular product. So, and it also gives you a lot of information about the VOCs and the contents of it. So be sure you have, no matter what one you're using, be sure you have those two documents handy before you start a project. Third thing we're trying to do is explore the appropriate applications for different release agent formulations. As I mentioned, a lot of misunderstanding in this category. Everybody thinks, without training, everybody thinks that more is better when applying release agents. They think, well, if I put on more, it'll get, it'll release better. That is just not the case. As I said before, thin is in. Thin is how you should apply a reactive release agent. You will save tons of money by not wasting product, and you'll get a much better concrete surface. Speaking of concrete surfaces, the industry has visual concrete standards. And this is just a chart showing, this is true for reactive release agents, showing the amount of product used and the type of surface that, if you use it as the manufacturer recommends, the type of surface that you will achieve. And a CS1, if you look down at the bottom, you'll see that that is 5/10,000ths of an inch of thickness of the release agent on the form in order to get the ideal type of surface. The more you increase that release agent on that form, the more bug holes you're going to see and surface imperfections. This chart goes up to a 6, and you see that is using 5/100ths of an inch thickness, which is very thick. You never want to achieve that surface. So ideally in architectural, we're going for CS1 or CS2. And you can see that the dramatic difference between by really laying it on. I've been in some plants where you can see people just hosing it on, and you want to avoid that at all costs. Reactive release agents are used for architectural, of course. We should always use that, but they're also used for structural and infrastructure as well. So everything from high-end office buildings and structures such as bridges, down to septic tanks and manholes and utility vaults. And the reason for that is because you'll get much cleaner forms, and your concrete will look better. Even if you're producing a septic tank as you're delivering that to the to the property. You want it to look good. You don't want it to be all stained and discolored. So, but it will protect your forms, and it will save you money over the long term with those forms. Ideal form liner materials are fiberglass, overlaid plywood, steel, and epoxies and urethanes. For structural, the ideal form materials are regular and oiled plywood, aluminum, and don't use, if you're making structural concrete, don't use foamed polystyrene or natural rubber. There are special release agents for those materials. And even when the quality of the surface is not a factor in infrastructure projects such as underground pipes, it's still ideal to use it to help make stripping easy and to keep those forms clean. So this will definitely reduce labor costs. Sustainability is so critically important these days. Release agents are subject to EPA regulations for clean water, air, and groundwater. Department of Transportation shipping regulations regarding flashpoints, and the USDA has they have a list of bio-based products. They have a certification program for that. So if you're interested in that, if you're working on a federal project, it's required that you use a bio-preferred release agent where possible. And you can find that list online through the USDA's bio-preferred program. I mentioned the problems with diesel before. There are all kinds of prohibitions against it. It's prohibited because the VOC emissions are contributing to smog. There are considerations as a carcinogen. Motor oil is a known carcinogen. If you're doing any project in California, you have to be alert to, they have a law called Prop 65 that lists over 1,200 cancer-causing ingredients for all kinds of different products. So you want to be sure that the release agent that you're using and other products are Prop 65 compliant. Release agents containing more than 25% diesel or home heating oils will not pass EPA regulations for VOCs in states enforcing the Clean Air Act. In the US, release agents have to meet the federal VOC limits of 450 grams per liter. That information, that data is on one of those two product sheets that I mentioned earlier. So be sure and check that to see what your release agent has. So it's 450 for federal. A lot of states and regions have a limit of 250 grams per liter. That's also true in Canada, all throughout the entire country. And some states have even stricter requirements. Southern California has a limit of not more than 100 grams per liter. So be sure and check the release agent that you're using to make sure that it's does not exceed those the standards in whatever state or country you're using it in. Combustibility is also a consideration. EPA, DOT, and OSHA agree that flammable materials have a flash point below 141 degrees Fahrenheit. For domestic transportation, the Department of Transportation defines combustible, some materials as combustible and therefore hazardous with a temperature in the range, a flash point in the range of 100 to 200 degrees Fahrenheit. The UN and DOT regulations for air and ocean transportation, they are different than ground transportation, so be sure and consult those if you're using air and ocean shipping. And products made with diesel, kerosene, mineral spirits, and other solvents fall into this confusing flashpoint range. So it's always important to check with the manufacturer to make sure that you're in compliance. I've seen significant fines levied against some companies for failure to do that. So, some of the advantages of low VOC release agents. They're non-hazmat. You can ship them just about anywhere. A lot of them are 100% vegetable-based formulations. No waxes, silicones, or carcinogens. They're solventless. They're non-toxic. They're significantly higher flash points, which is a good thing. You want a high flash point because you don't want that low flash point. And you want to achieve VOCs less than 5 grams per liter. There are a lot of release agents on the market out there that meet that standard, 5 grams per liter or less. We have a release agent, a synthetic, that is even better than that. It has 3 grams per liter. You want to comply with all federal, state, and local regulations requiring VOC ratings that less than what I mentioned earlier. Now, we as a manufacturer, and I'm sure all manufacturers, keep regularly updated on those laws. And so we make sure that before we ship to a particular area, that product is in compliance with that area. Low VOC release agents must meet ASTM biodegradability rule of reaching their half-life in 28 days. They should be 100% biodegradable formulations. They're either 100% vegetable-based, certified bio-based, and you see the bio-based symbol up there on the right-hand side of the screen. There are about 30 different release agents that qualify for that certification by USDA. At last check, there were about a dozen release agents that are for architectural concrete. So if you're looking for one, you can always find that list on the USDA website. And in addition to release agents, there are other treatments that are available out there, and I just wanted to briefly touch on those and let you know what's available. These are accessory treatments that can be applied to forms, equipment, and tools to reduce your labor cost and to extend the life of the forms. Additives are incorporated, so release agents will bond better to the form and create cleaner separation. And they improve the form removal from sticky mixes. There are also rust preventatives out there. You got to treat those steel forms very preciously. So you want to apply a rust preventative to that form if you're using it or if you're storing it for any length of time. That will create a barrier against moisture and vapor. It won't harden or gel, but it will stay oily on that form surface. And you can use that as a release agent when it is time to use the form. There are also rust removers, water-based, biodegradable, non-flammable. They remove rust and concrete buildup on steel forms or equipment. They are quality rust removers. They meet or exceed VOC regulations in all states. They're safer for the skin than inferior products, and they should be used before pouring concrete or painting. So keep in mind that that's available. There's also spatter protection available from several manufacturers. And what that is, you put it on anything that comes in contact with wet concrete, and that will prevent the concrete, even if it hardens, from sticking to the surface. That could be a ready-mix truck, it could be a paving equipment, it could be a sprayer, a mixer, whatever it is that comes in contact with concrete. You use that spatter protection, and it saves you all that hours of cleanup at the end of the job. Some formulation considerations are chemically active versus barrier, freeze damage. I didn't mention, but water-based release agents are out there. They're available, and they're good. Ideally, what you want to do is lay down those molecules on the form surface and have the carrying agent evaporate. That's great with water. But if you're using it in conditions where there could be potential freezing, that can cause problems. And it can cause that product to separate if it's sitting out in a yard and it freezes, and it would have to be remixed. Color considerations. There are formulations out there that are that appears with a straw color, white, light blue, or even clear. Coverage. How much? There are a lot of different on those product specification sheets that I mentioned. You look at the recommended coverage that you get from a gallon of that release agent, and those can vary anywhere from 500 square feet per gallon to 2,000 square feet, or even higher. So that's a consideration to look at when you're working with that. And the effect on the concrete surface. You want to avoid dusting. You want to make sure it's paintable if that's what you're going to do with it, or stain it. It's going to be non-staining, which means you don't want that to have blotchy areas on that concrete surface. It's got to be compatible with admixtures that you're using. So consult with your admixture company and your release agent company in order to make sure that there's no incompatibility there. And it's got to be compatible with the form liner material that you're using. All different kinds of form liner material. We have a lab that tests. We work with all of the major form liner companies. We test every material that they've sent to us, and that's critical lab testing on all kinds of different elements to make sure that there is no incompatibility there. Flash point's important. Gas, if you use gasoline, that has a flash point of 50 degrees or less. Diesel is 115 to 185. Low VOCs release agents are typically greater than 220 degrees Fahrenheit, and a water-based release agent, and that has no flash point at all. VOCs of some common materials. This is why diesel is so bad. It's the national standard is 450. Diesel has a VOC content of 860 grams per liter. Low VOC release agents are typically in the 160 to 245 range. And as I mentioned, they can be a lot lower. And water has no VOCs, water-based release agents. So some of the testing that we go through in the lab and other manufacturers go through, we look for buildup, we look for dusting. We want to reduce the number of bug holes as possible in that formulation. And you want to avoid color variations. You want a consistent color throughout. Some of the field testing that we do is we look at cold temperature issues, how it affects the spray pattern in your spray equipment. We test it in a refrigerator, in a glass jar, freezer. We look at skin reactivity. We look at form layer failure. We determine whether a release agent will wash off in the rain. Well, we also look at color, the cloudiness, how that affects the sprayability and the quality. Form liner failure is an important test that we do. We test that durability by using them with every one of our release agents and doing formal tests. And then we provide the manufacturer of the form liner a finished scientific report showing just what the results are. We check for swelling, softening, or a gooey residue. So we look at whether release agent washes off in the rain. So all of those are important considerations that we look at. So if you're working with any of the major high quality manufacturing release agents. They're going to be doing these tests to assure that is compatible for you. And also you look at or talk to the form liner company to see what they recommend. Our fourth objective is to consider steps for applying release agents. And that is probably the most misunderstood category of all in dealing with release agents. Barrier release agents, those form oils, those petroleum-based oils, they release better when they're heavily applied. So you need a lot more of a barrier release than you do of a chemically reactive release. So you apply it very thin. In order to achieve that, you need the right equipment in order to apply it. You see somebody wiping the form. That's always a good idea if you're having an architectural project and you want to get the absolute best results, even if you're using an inferior sprayer, one that doesn't achieve the right PSI or doesn't have the right spray pattern, wiping it with a fine micro fiber cloth gently will help ensure that you get the best surface quality. So this is just showing you that the more release agent you use, the higher the cost is going to be. So you want to use it according to recommendation in order to get the best surface quality and to save money. All right, spray equipment. 90% of what I see out in the plants that's being used are the typical spray canister where you pump it up and then you spray it on to the form. Every one of those doesn't reach the right pressure in order to get the best coverage for the release. So ideally, in order to get the right spray pressure, you want to make sure the right tip is used and it's the right temperature conditions. So there are three types of sprayers out there, three main categories, all kinds of sprayers. But those three categories are compressed air, electric sprayers, and the manually operated sprayers. The compressed air sprayers are the best because you achieve we recommend a PSI of 60 to 70 when applying, and that will deliver that at a consistent rate. Electric sprayers are also a good option, but they tend to be more expensive. And then you've got the manual sprayers, which are typically about 2 gallons of product in it, and they continually lose pressure as you go along, and it typically does not have the right type of spray tip. So speaking of spray tips, there are different types. There's the flat type spray, the cone type spray. There are hollow cone tips, there are full cone tips. So be sure you look at the manufacturer's recommendation in order to use the right tip. A lot of those sprayers just come with a what's called an 8001, which is your basic spray tip. We recommend for architectural concrete that you use a very fine tip, which is at 800067. Those numbers are on each tip, and that's how you order them. We sell them. I'm sure a lot of other manufacturers sell them too. The first two digits represent the spray angle, and the last digits represent the flow of water through the tip at 40 psi. And that's just showing you the spray patterns that you get with different types of tips. So low winter temperatures will increase the viscosity of oil, potentially ruining the spray pattern. So that's always a consideration. And you use a premier carrier oil that doesn't thicken until temperature drops below 15 degrees. Winterizers can be added, but you've got to really be careful about the VOC content of those winterizers. And some of those winterizers can cause dusting on your finished concrete. So be careful of that. Application steps, there's 8 of them. You prepare the form, make sure it's good, clean, ready to use. You apply the form release. with in a very fine mist. You want to atomize that release agent onto that form surface and don't use too much of it. For architectural, you wipe the form surface, then you pour the concrete, you consolidate the concrete, you cure the concrete, you strip the forms, and then you clean the forms and take very good care in storing them. Just a very brief case study. We worked with Clark Pacific on Levi Stadium, if there's any 49ers fans watching. We used it because it's California. We used an eco-friendly formulation that maximized the visual impact and mimicked the form surface for this project. We used 4,000 pounds of architectural concrete release agent were used on the project, and it was applied using backpack sprayers at the sufficient PSI to achieve that ultra thin film on to achieve that CS1 finish. And it resulted in a superior finish for visually stunning concrete surfaces without bug holes. So if you're ever at a game at Niner Stadium, check it out. All right, in conclusion, I hope you have a better understanding of how important release agents are when attempting to accomplish a beautiful bug-free whole architectural concrete building with a high visual impact. The cost of using agents is negligible. It's very minimal when you consider the time saving in cleaning and the money saved by having to replace forms and having to clean forms. So form release agents ease the formwork removal, extend the useful life of the form, and improve the smooth and texture of the concrete surface. So I thank you for joining us today and listening to this presentation. If you have any questions, I think we have a little bit of time to answer those. Feel free to send a message, and we'll answer whatever questions you have.
Yeah, I will put that back up here. We did have a couple of questions come in. Get it here. Let's see, where are those questions? Here we go. One, Jim, is does a release agent contain any ingredients that will cause issues with sealing or painting the stripped concrete?
That depends on the release agent that you are using. I mentioned before, some release agents contain waxes or silicones. A lot of the European release agents will have a wax base in it, and that can cause some issues with treating that surface after. So you got to make sure that you look at what the ingredients are in whatever release agent you're using.
Very good. And the only other one I've got here is our concrete is sticking to our form in spots. Is the form oil bad?
Most likely not. Usually when you see sticking on a concrete form, that is the result of a sticky mix. It could be a misapplication. They could have missed a couple spots when spraying down that form. And also, today's new formulation with the type 1L cement, we're seeing some situations where with some typical form oils being used, that they're not getting a sufficient release in order to create the ideal separation. So that formulation from the release agent companies is based on your typical Portland cement. So if you're getting some kind of sticking, there are products out there that have an ingredient to facilitate additional release. We've got a product called Poly Release that we can put in some formulas for sticky mixes.
All right, well, that about wraps it up for today. Jim, I very much appreciate you participating and sharing this information with our members. And thanks for your support, and thanks for putting on this presentation today.
Oh, you're welcome, John. Thank you. And thank everybody for watching.
Thanks, everyone. Have a great day.